Okay, we're going to start today by going over the second half of assignment 26. So let's take a look and see what we have here. It says, write balanced equations for the following by first deciding the type of reaction, predicting the products, and then writing the equation. So number one, we have magnesium and oxygen gas. So we need to write the formulas for this element, or for these two elements. Magnesium elemental is Mg. Oxygen gas is one of our 7 diatomic elements, so it's not just O, it's O with a subscript 2 after it. It comes in pairs in its elemental form. This reacts to form, well, let's see. Magnesium, when it forms a bond, has an oxidation number of 2+, and oxygen, in an ionic compound, we are going to have a oxidation number of 2-. So 2+ and 2-, one of each will cancel the charge, so we have MgO. Of course, this isn't balanced, so we need to get 2 oxygens over here. We'll have the coefficient 2 in front of MgO. That gives me 2 magnesium, so I'll put the 2 in front of magnesium on the left side of the equation. Number 1 is finished. You'll notice that this is a combination of elements. We call this a synthesis reaction. Number 2, elemental aluminum, Al, and hydroiodic acid. Now, of course, the prefix hydro, you've learned, means that this is a binary acid. That means it's composed of hydrogen, and in this case, iodine. Hydrogen acting as a metal with a 1+ charge, iodine with a 1- charge, so one of each will work, Hi. Now, this will react to form, and we have a single displacement reaction here where aluminum and hydrogen will switch positions. So hydrogen now will be by itself as the diatomic element H2, and aluminum and iodine will form an ionic bond together. Aluminum's oxidation number is 3+, iodine is 1-. So the formula would be an aluminum and 3 iodines. I need 3 negatives to balance out the 3 positive charge from aluminium. So this one's a bit more difficult to balance. We have 3 iodines here. We'd like to put a 3 in front of Hi here to give me 3 iodines, but then you'll notice that the hydrogens won't balance. So I think I'm going to fix the hydrogens first. I'm going to put a 3 in front of H2. Now that gives me 6 hydrogens. And then I'm going to put a 6 in front of Hi. Now notice, of course, my hydrogens are now balanced. That gives me 6 iodines. So I can put a 2 in front of Li3. That gives me the 6 iodines that I need. I have 2 aluminums required on the reactant side, so I'll put a 2 over here. This, by the way, is called a single replacement reaction. And some textbooks call that single displacement. It's the same thing. Okay, you'll notice on number 3, we just have a compound, sodium chlorate. So this is going to be a decomposition reaction. Let's figure out the formula here. Sodium has an oxidation number of 1+. Chlorate is one of your polyatomic ions. Let's look that up quickly on your polyatomic ion chart. And you can see that the chlorate ion is ClO3 1-. So let's see. ClO3 1-. We have a positive 1 and a negative 1. So we just need 1 of each to balance the charge. Now it turns out that metal chlorates always decompose into the same things. Metal chlorates, when heated, decompose into metal chlorides and oxygen gas. Well, the metal chloride in this case will contain sodium, that's my metal, and chloride, that's Cl-. So I'll make NaCl and oxygen gas. Now, to balance this, we'll put a 2 in front of sodium chlorate, a 2 in front of sodium chloride. Now I need 6 oxygens on the product side, so I'm going to put a 3 in front of O2. This is called a decomposition reaction. So metal chlorates, remember, always decompose into metal chlorides and oxygen gas. Okay, number 4, zinc chloride. Zinc's oxidation number is 2+. Chloride, we just saw in the previous problem, is Cl negative. Ammonium. Ammonium is another polyatomic. It is a positive polyatomic. It's NH4 with a positive 1 charge. So, NH4 positive 1. Sulfide comes from sulfur, whose oxidation number in this case is 2 negative. So on my reactant side, I will have the compound ZnCl2. I need 2 chlorides to balance out the 2 positive from my zinc. And I need 2 ammoniums. So NH4 in parentheses with a 2, and then S. Reacts to form. Now this is a double replacement reaction, where the positive ions will switch positions. So zinc and sulfur will get together. Zinc is 2+, sulfur is 2 negative. So we make ZnS. And ammonium and chloride will get together. Ammonium's 1+, chloride's 1 negative. So we end up with NH4Cl. Of course, this isn't balanced. We can quickly fix that by putting a 2 in front of NH4Cl. This, once again, is called double replacement, and it's often called metathesis, or some pronounce it metathesis. Alright, next up, number 5, we have mercury 1 nitrate and cadmium bromide. Now, it says use Cd2+, that's the oxidation number reminder for cadmium, and mercury 1 is sort of a diatomic ion. It's 2 mercuries with a positive 2 charge. So let's work on this formula. If mercury 1 is Hg2 with a 2 positive charge, and nitrate, let's look that up on our polyatomic chart. Don't get that confused with nitrite. We want nitrate is NO3 negative 1. So, NO3 negative 1. It looks like I'm going to need 2 nitrates to balance out the 2 positive charge from my mercury 1. So that formula is Hg2 parentheses NO3 with the 2 there. Okay, we react that with cadmium bromide. Just a reminder, cadmium's oxidation number is 2+. Bromide, group 17, has an oxidation number, in this case, of negative 1. So we have CdBr2. Reacts to form. Well, another double replacement reaction. So mercury and cadmium will switch positions. Cadmium will be with nitrate. So cadmium's 2+, nitrate's 1 negative. So CdNO3 2. And the mercury 1 will be with bromide. So mercury 1, remember, is Hg2 2+, and bromide is Br negative. So we have Hg2, Br2. Now, to balance this, let's take a look. 2 mercuries, 2 mercuries, 2 nitrates, a cadmium on each side, and 2 bromines on each side. This is balanced as it's written. This is another example of a double replacement reaction. Okay, number 6, chlorine gas. Now, elemental chlorine is a diatomic element. That's Cl2. And lithium iodide. Lithium in group 1, positive 1. Iodide, iodine from group 17, negative 1. So we have LiI. Pretty straightforward. Now this looks to me like a single replacement reaction. But here we begin with a nonmetal. So chlorine will not switch with lithium, which is a metal. Chlorine will switch with the iodine. They are both nonmetals. So iodine will come out by itself. It is also diatomic. And lithium will get together with chloride. Remember, lithium's 1+. Chloride from group 17 is 1 negative. It is LiCl. This is easily balanced. We'll put a 2 in front of LiCl and a 2 in front of LiI. This is, of course, as we mentioned, an example of a single replacement reaction. Okay, next up, sulfuric acid. Now, sulfuric acid is not a binary acid. It does not begin with hydro. So this is called an oxy acid or a ternary acid. Sulfuric come from 8 polyatomic ions. So we'll look for sulfate. Sulfate right here. SO4 2 negative. So we have SO4 2 negative. And we will have our hydrogens acting as a metal with a positive 1 charge. So the formula for sulfuric acid is H2SO4 plus potassium hydroxide, potassium positive 1, hydroxide, that's one of our polyatomics that ends with "ide" instead of "ate" or "ite." So let's look it up. Hydroxide, OH negative 1. So we end up with KOH. Now this reacts to form. Well, let's see. It's like we have another double replacement reaction. So H and K will switch positions. K will get together with sulfate. Keeping in mind when potassium forms a bond, has a positive 1 oxidation number, sulfate is a polyatomic with a negative 2. So we have K2SO4 plus H and OH get together. Now H will act as a metal with a positive 1 charge, hydroxide's negative 1, so we have HOH, but we usually write that as H2O. Okay, to balance this, it looks like I need 2 potassiums here, and then I have a total of 2 plus 2 more hydrogens for 4. If I put a 2 in front of H2O, that balances. Once again, this is an example of a double replacement reaction. Okay, number 8. Let's see, we have sodium. Elemental sodium is Na. Chlorine gas, it's a diatomic element Cl2. So we have another synthesis reaction, like we did with number 1. When sodium forms an ionic bond, it has an oxidation number of positive 1. Chlorine, in this case, negative 1. So we have NaCl. We'll put a 2 in front of the NaCl and a 2 in front of the sodium. Once again, this was an example of a synthesis reaction. Alrighty, moving on to number 9. Boy, a bit more than halfway through here. So, number 9 is another decomposition reaction. And this happens to be a metal carbonate, barium carbonate. Now barium is in group 2, has a 2 positive charge when it forms a bond. Carbonate is one of our polyatomics. It's CO3 2 negative. CO3 2 negative. So we have a 2 positive with a 2 negative. We end up with needing 1 of each, BaCO3. Now, when heated, metal carbonates will always decompose to form metal oxides and carbon dioxide. So one product, of course, will be carbon dioxide. The other will be a metallic oxide. My metal's barium. So barium, when it forms a bond, is 2 positive. Oxide comes from oxygen, which is 2 negative. So we have BaO. Now, this one is pretty easily balanced. 1 barium on both sides, 1 carbon on both sides, and 3 oxygens here. 1 plus 2 is 3 more. So this is an example of a decomposition reaction. Keeping in mind that metallic carbonates, when they are heated, will always decompose to form metallic oxides and carbon dioxide. Okay, moving on to number 10, elemental tin, Sn, plus copper 2 nitrate. Okay, a Roman numeral. Now those are always simple because the Roman numeral tells us the charge of the metal. So copper 2 means copper's 2 plus. It does not mean that there are 2 coppers. Nitrate is a polyatomic. We've seen that earlier in this assignment. Let's look it up again. Nitrate, NO3, negative 1. Oh, sorry, I put that in the wrong spot. So we have a copper 2 plus and a nitrate, which is 1 negative. So we need 2 nitrates to balance the charge. Now, this looks like a single replacement reaction. Tin is a metal, it will switch with copper, which is a metal. So copper's all by itself. And tin will get together with nitrate. Now, tin can have multiple oxidation states. In this case, I'm telling you to use tin 4 plus. So if I do that, tin being 4 plus, and nitrate, as we've already seen, is 1 negative, the formula would be SN, parentheses around the nitrate, and we need 4 of those to balance the charge. Now to balance this equation, I need 4 nitrates on this side, so I'm going to put a 2 in front of copper 2 nitrate. That gives me 2 coppers, so I'll put a 2 in front of copper here. And I'm finished with number 10. This was an example of a single replacement reaction. Number 11, vanadium 3 nitrate. Vanadium is 3 positive. I've learned that. The Roman numeral tells me the charge of the metal. Nitrate, we just saw on the problem above, is NO3, negative 1. So the formula would be V, parentheses around the NO3, with the 3 on the outside as a subscript, plus potassium carbonate. Potassium positive 1. We saw earlier, carbonate's one of our polyatomics, CO3, 2 negative, so we have K2CO3. Now, are you picking up on this? Do you notice that this is another example of a double replacement? Vanadium and potassium will switch partners. Vanadium 3 plus will get together with carbonate, which is 2 negative. So to write that formula, we have to find a number in common between 3 and 2, which of course is 6. So to get to 6 positives, I need 2 vanadiums. To get to 6 negatives, I need 3 carbonates. Plus potassium and nitrate will get together. Potassium's 1 plus, nitrate is 1 negative, so we form KNO3. Alrighty, to balance this, looks like I need 3 carbonates, so I'm going to put a 3 there. I need 6 potassiums, so I'm going to put a 6 here. Now that gives me 6 nitrates. I have 3 over here, so I'm going to put a 2 in front of vanadium 3 nitrate. That gives me the 2 vanadiums required to balance. Once again, that was an example of a double replacement reaction. Number 12, lead, Pb, and silver acetate. Now silver, its oxidation number, remember, is always positive 1. Acetate is a polyatomic. There are 2 ways we can write it. C2H3O2 negative 1 is the way I normally do it, but you'll often see it as CH3COO negative 1. They are the same. So let's use C2H3O2 negative 1. So the formula, the equation is elemental lead. Looks like silver's 1 plus, acetate's 1 negative. So we have AgC2H3O2. Reacts to form. Let's see, a metal will replace the metal. So silver will be by itself. This is similar to the lab we just finished. And lead will get together with acetate. Now lead can have multiple oxidation states, and in the instructions I tell you to use lead 2 plus. So if I use lead 2 plus with my acetate, the formula will be Pb parentheses C2H3O2, and I need 2 of those because they're 1 negative each. Now, to balance this, we have 2 acetates, so I'm going to put a 2 in front of silver acetate. That requires 2 silvers, so I'll put a 2 in front of silver. This was single replacement. Okay, number 13. Calcium, elemental calcium is Ca, and nitrogen gas. Nitrogen's another one of our diatomic elements. So it's N2 in its elemental state. Now this looks like a synthesis reaction. 2 elements combining to form a compound. Calcium is 2 plus when it forms a bond. Nitrogen is in group 15. That's 3 negative. So a number in common between 2 and 3 is 6. So Ca3 to give me 6 positives, and 2 to give me 6 negatives, and the charge is balanced. Of course, the equation's not. We need 3 calciums on this side. So that was a synthesis reaction. Number 14, strontium hydroxide. Strontium, Sr, 2 positive, it's in group 2. Hydroxides, a polyatomic, we saw earlier in this assignment, OH negative. So we have Sr, parentheses around the hydroxide because we need more than one of those, with a 2 on the outside. Nitric acid. Now remember, this is not binary because it does not begin with hydro. So that means it's a ternary or oxy acid. Ics come from ates. Now we've seen nitrate a few times on this assignment. Remember, NO3, -1. Hydrogen acts like a metal in this case with a +1 charge. So we have +1 and -1. The formula for nitric acid is simply HNO3. Double replacement. Strontium and hydrogen will switch partners. Strontium will get together with nitrate. Strontium 2+, nitrate 1 negative. So Sr, parentheses NO3 2. And H gets together with OH. Remember, we like to write that as H2O as opposed to HOH. To balance this, I need 2 nitrates. So I'm going to put a 2 in front of HNO3. That gives me a total of 2 plus 2, 4 hydrogens. So I'm going to put a 2 in front of H2O. And the oxygens take care of themselves. This, once again, is double replacement. And the last one for assignment 26, part B. Iron 2 sulfide. Iron is Fe with a 2+ charge. Iron 2 tells me that it's 2+. It does not mean that there are 2 irons. It means the oxidation number of iron is 2+. Sulfide comes from sulfur, which is in group 16. It's 2 negative. So FeS is the formula for iron 2 sulfide. Hydrochloric acid means it's a binary acid. We have hydrogen acting as a metal with a 1+ charge. Chloric comes from chloride, which is 1 negative. So we have HCl. Looks like another double replacement reaction. Iron and hydrogen will switch. So iron 2+ gets together with chloride 1 negative to form FeCl2. Remember, iron was 2+, chloride 1 negative, FeCl2. And H1+ will get together with S2 negative, so H2S. To balance this, I need 2 chlorines and 2 hydrogens on the reactant side, so I'm going to put a 2 right there, and it's done. And this one is an example of double replacement. There we go. Assignment 26B completed.